Hey everybody, this is video number 2 of 3, and in this video I'm going to show you when your sequence of transformations is a translation and a reflection. And you won't be told you need to do these two things, but I'll show you why it's those two things here. And this page of notes is completely filled out, and basically it's because now as you do future questions in this document, you can kind of use my work and just copy and paste and then change whatever letters you need to change. But as it says here for number 1, in this diagram below, triangle JHK is the image of triangle DFG after some sequence of rigid motions. And remember, it says after a sequence of rigid motions. So there's many right answers. I'm going to give you just one of those many right answers. But as I have right here, use this link to work this out in Geogebra. So I'm going to show you how I was able to create this image that you see right here, where you are going to create something like this from that in the future question. So let me show you what I did. So if I click on this link, it will take me to Geogebra, and it'll take me to that same picture that I started with. And so first of all, it told me again that triangle JHK is the image of triangle DFG. So let me move my face out of the way here, first of all, so I can find my tools. And I'm going to grab my pen tool first. And I want to label that if they told me that the triangle JHK is the image, I'm going to label this one with an image, I for image, and then this one is your pre-image. Okay, PI for pre-image. That one got a little sloppy, but okay. And then here's the next thing. So always, always, always decide which one comes first and which one comes second. Then they called this triangle JHK. So if I look at JHK and I follow the order of those letters, I can see that the order of these letters, JHK, follows the hands of the clock. That's clockwise. And then the orders of triangle DFG, D, then F, then G, does not follow the hands of the clock. This is counterclockwise. And that's, like I told you right from the get-go, is first check what came first, what came second, then check your orientation. And that will tell you what should happen as a result. So in order for this triangle DFG to be mapped onto this triangle JHK, a line reflection must have occurred. Now, one of the things that you notice I did is I tried to minimize the size of these. So if you right click on this or you click on it, you can bring up its settings. And if you go to style, you can change the line thickness way down to from 10 all the way down to 1 to just kind of like make it not as bam right in front of your face. So that's that one. And I also like to do this. I'm going to change the color to blue. So that's to match the color of what this one is. And then I'm going to do the same thing here, kind of right click on it, go to settings, style, make that just a thin line. And I'm going to change the color of this line also to match the green triangle. Okay, so just want to get them kind of faint and out of the way, and I have still my pre-image and image. So I've decided I'm going to do a translation first, then a reflection second. And so what I want to do is I want to take this triangle that is the pre-image and I want to move so that I'm going to translate it so that one of the points of the pre-image maps onto a point here. And we don't have to do that. That's just a suggestion. I don't have to, but if I just go here and go to the transform tool, translate by vector, and I know based on the mapping that, for example, the point F maps onto point H. If you look at triangle DFG, that's the second letter, and JHK is the second letter. So I'm going to click on the point. First when I do this, it says I need to select the object that I'm going to translate. That's the triangle. Then I'm going to go from point F to point H, and boom, there's my translation. Now, I want to make this triangle not so obvious. So first thing I'm going to do is I'm going to click on it. I'm going to make it from a solid line to a dashed line. I'm also going to change the color of it, make it some other color. Okay, so now I have what was triangle DFG is now triangle D prime, F prime, G prime. Sorry, let me get that out of the way. That's my new triangle. Also don't need that. Here's my new triangle that's in red. Now I can see where the line of reflection is. My line of reflection is the line that goes through these points here and here. That's my line of reflection. And again, let me make this line something different, like a nice little dotted line or something like that. Come on, there you go. Okay, and I also want to consider, so I have my translation that moved the triangle, the pre-image down to this intermediate triangle that I left as a dotted line or dash line, and then here's my line of reflection, and I just want to get an idea of what that line is. So I might need to zoom in so I can see right here, and I'm going to grab my pen tool. This number right there is going to help me determine the equation of this horizontal line. So when this horizontal line crosses over the y-axis at -2, then I know that this equation of this line is y equals -2. Okay, so now I know here's my translation, and then here's what the equation of the line is. So what I did from this point is I took a screenshot of this image, and that's how I got into, that's how I dropped it right here. So you pretty much see almost the same exact thing. The only thing I did different was the first time I did it, I used point G and to map onto this point over here, K, but it doesn't matter because when you translate, all the points translate the same distance and direction. So here's what my picture now looks like after that. So I upload that image and insert the image right here, and then I'm going to describe the sequence. I'm describing my sequence. This is the way I did mine. I have triangle DFG, and if you're looking for where this came from, I used the insert equation option, and then you have these choices. When you insert a new equation, you have different operations to use, but you can just copy mine and then change the letters and as you do previous questions or future questions, I'm sorry. So I have this triangle DFG turned into or transformed the triangle D prime F prime G prime by doing a translation of 7 units to the right and down 2. So that describes what got me from here to here. Then I used triangle D prime F prime G prime turned into or transformed into triangle JHK by doing a reflection over the line y equals -2. So that is my complete answer to part A. I included my picture and I described my sequence. Your sequence could be different if you decided to map point D onto point J. Then you're going to reflect over a totally different line than what I did, or you might not even move it down. You can just move it over and reflect over a different line. But either way, no matter what you do, you have to have some kind of translation and line reflection. It'll be up to both myself, Mr. Briggs, whoever's looking at your question to make sure that what you did actually works. Now here's part B. It says, use properties of rigid motions to explain why triangle DFG, my original triangle, has to be congruent to the triangle JHK. I told you when you see this, basically, you, like literally just cut and paste what I said right here. We did both a translation and reflection. So I just said translations and reflections are rigid motions because they maintain size, aka distance, and shape. I cut and paste. I should think you should do too. And then here's the last part. This is the sort of a new step here. But if these triangles are congruent, as we just explained why they have to be congruent right here, then here's a list of all the corresponding sides and corresponding angles that now must be congruent, because when the triangles are congruent, all the parts, aka sides and angles, must be congruent. And so when I come up with this list, again, I used the equation tools here to have the actual symbols. So you see segment DF is congruent to segment JH. You can look at the picture and say that the segment DF would be the one that maps onto segment JH. That's one strategy. Or the congruent statement right here. This is called a congruent statement. When you say triangle DFG is congruent to triangle JHK, the order of those letters is important. And you see how like DF is the first 2 letters of DFG, JH is the first 2 letters of JHK. So those 2 segments have to map onto each other. And then here's DG, that's first and third of these letters, and JK, first and third. And then the second and third FG is congruent to the second and third HK. Those are all 3 pairs of corresponding sides. Then when I did the angles, I'm just mapping the angle D to the angle J, the angle F to the angle H, the angle G maps onto angle K. Those angles must be congruent. Okay, so that kind of walks you through both the learning objectives of today, and also when you have the orientation changed, then you must have had a translation with a line reflection. Okay, so that is the end of video 2, and come back for video number 3.